Let's look at another question today. The question number is 1249 and the title says minimum remove to make valid parentheses. Now this is not one of the most difficult questions which I have solved on my channel, but this certainly is an interesting one, especially for people who have difficulty in understanding the concept of stacks. This can be a very good exercise. Now let's look at this question. The question says that you have been given a string which has opening and closing parentheses and lower English case characters. You have to remove minimum number of parentheses to make it a valid string. Now I'm going to use my own solution, my own technique to solve this question, which uses two stacks. Uh, let's look at that technique. Now let's take the example given in the question. It says LLE8. Let's mark the position indices 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, if you think about this question and just brainstorm it a bit, you will understand that the English characters doesn't really matter. You just have to look at the parentheses because those are the things which you have to consider while solving the question. Now, in this case, let's say we just look at the parentheses which are given like this. Now, in order to make this a valid string, you can see that we have to remove one closing parenthesis because as you can see, there are two opening parentheses and there are three closing parentheses. So of course, the closing parentheses are more, and this is just one extra, so we have to remove one closing parenthesis. And you can remove any of the closing parentheses to make it a valid string. As you can see in the example explanation, there can be multiple solutions to the same incoming string. Now, how we do that? I'm going to use two-stack technique to solve this. So stack 1 will contain the parentheses and stack 2 will contain the position of these parentheses. And this stack 2 will be used to remove the parentheses which are extra in the given string to make it a valid string. Now how we do that? So basically what we do is we iterate over this the list of characters in the given string, and we do basic uh, operations on this given characters to fill these stacks. Now what we do is, so basic algorithm is we have to consider three things. One, if it's an English character, just ignore. If it's an opening parenthesis, then add that parenthesis to stack 1 and add position to stack 2. Now, if it's a closing parenthesis, then you have to see if the stack is empty or not. So if the stack is not empty, is not empty, or let's say if the stack is empty, let's just take the case when the stack is empty. If the stack is empty, we just add the character to the or to the parenthesis to the stack. And if the stack is not empty, then we check what is the topmost value on the stack. So if the topmost value on the stack is an opening parenthesis, if it's an opening parenthesis, then it can cancel out the current closing parenthesis. So if it's an opening parenthesis, it can cancel out the current closing parenthesis. So what we do is we pull the topmost position from the stack and we just move to next character. If it is a closing parenthesis, then it cannot cancel out the current closing parenthesis. So we just add the current closing parenthesis to the stack. Add it to the stack. Now I'm going to explain this using the example we have taken above. Let's take this again here. L E E. Let's mark the positions. Now let's take two stacks. Stack 1, stack 2. Now stack 1 is for the parentheses as I said, and stack 2 is the stack which will contain the position or the indices. Now we start from here and we see that the first position 0 is L, English character, we ignore it. We move to E, again English character, ignore it. We move to another E, position number 2, English character, ignore it. So when we move to 3, we see that it's an opening parenthesis. So we simply add it to the stack and we add the position over here 3. We move to T, ignore it. We move to another opening parenthesis which is on position 5, and we just add it to the stack and we add the position 5. Now we move to C, another English character, skip it. We move to 7. Now it's a closing parenthesis. Now when you see a closing parenthesis, you have to see whether the stack is empty or not. So as you can see, the stack is not empty, and the topmost position here, it's an opening parenthesis or an opening braces. It can cancel this out. So what we do is we just remove the topmost position from stack 1 and stack 2. So this simply means that the current position 7, which is a closing parenthesis, was cancelled out by the opening parenthesis previous in the stack, and the position was 5th. So basically 5th cancelled out this 7. Now we move to 8. It's an English character, we ignore it. We move to 9. It's a closing parenthesis again, and then again we check whether stack 1 is empty or not. So now the stack 1 is not empty. We have to check what kind of top value it has. Now as you can see, it's again an opening parenthesis, so definitely this can cancel this out. So as you can see that this can cancel it out, or basically the third position opening parenthesis, this one can cancel out this one. We'll just pull this out and pull this out too. And now we move to 10. So we are now at position number 10. It's an English character, we skip it. We move to E. It's an English character, we skip it. Now we move to 12. And now it's again a closing parenthesis. Now remember, when it's a closing parenthesis, we always have to check whether the stack is empty or not. If the stack is empty, we simply add the position on the top of the stack. So we add top position 12 on stack 2 and the parenthesis in stack 1. So this simply means that this is the extra character which we can remove to make this a valid string. Let's look at another example. A, B, C, and D. Stack 1 and stack 2. Now we start from here. We see A, we skip it, we move to position number 1, closing parenthesis. Now when we move to closing parenthesis, we see if the stack is empty or not. So the stack is empty. We just simply add it to the stack 1 and we add the position over here. We move to B, it's a character of English letter. We skip it, we move to 3. We see it's an opening parenthesis. We simply add it to the stack and we add the position over here. Now we move to C, we skip it, we move to 5, we see closing parenthesis. Now again, it's a closing parenthesis. Whenever you see a closing parenthesis, you have to check whether the stack is empty or not. If the stack is not empty, we have to check the topmost position and see if it can cancel it out. If it can cancel it out, we pull the positions out from both the stacks and we move ahead. If it cannot cancel it out, we simply add it to the stack and we then move ahead. So now as you can see, we are on position number 5. It's a closing parenthesis. We look at the top of the stack as it's not empty. We see that it can cancel it out. So we will just pull this out and we will move on to the next position, which is D, and we skip it. So as you can see, we were able to find out that opening the closing parenthesis is an extra, which is at position number 1. So when we remove this will become a valid string. Now let's look at another example to show the conditions again and make it clear. A simple one, 0, 1, 2, 3. Now we take stack 1, stack 2. Now what we do is we look at the characters. Now we see that it's a closing parenthesis. Stack is empty. We simply add it and we add the position. We again look at another position number 1, closing parenthesis. Now stack is not empty, but the topmost position has a closing parenthesis which cannot cancel out the current position. So we simply add it to the stack 1 and we add the position number 1. Now whenever we see an opening parenthesis, we simply add it to the stack. We don't do anything. It's an opening parenthesis, just add it over here. Sorry, that should be that parenthesis 2, and we see another 3 or another position number 3. It's an opening parenthesis. We just don't do anything. We simply add it to the stack and the position. Now in this particular case, stack 1 says that these all parentheses are extra and the positions are these. So we simply have to remove all of them to make it a valid string, which will be an empty string. So in this way, we can use two stacks to find out the extra parentheses and their position to be removed from the stack. Now let's look at the code. I'm going to pull my latest submission to show you the code. Now this is the code to solve this question. It's going to use the same technique which I just discussed. Now it uses stack 1 and stack 2. Stack 1 is for the parentheses, stack 2 is for the position of those parentheses. We iterate over the string, and for each character we check if it's an opening parenthesis or it's a closing parenthesis. If it's an opening parenthesis, we simply push that character into the stack 1 and its position to stack 2. If it's a closing parenthesis, then we have to check two things: if the stack is empty, or if stack is not empty but the topmost position is a closing parenthesis, then we just simply add the current closing parenthesis to stack 1 and its position to stack 2, because it cannot cancel it out. Else we just simply pop the topmost character from stack 1 and its position from stack 2. So for example, if the case is, let's say, this one, when we iterate over the string characters and we move from left to right, what we do is we skip LEE because these are English characters, and then we move to opening parenthesis, we add it to the stack 1 and its position to stack 2. We skip T, we move to another opening parenthesis, we add it to the stack 1 and its position to stack 2. Then we move to C, we skip it, then we move to another closing parenthesis. And the closing parenthesis basically cancel out the topmost position on stack 1. So we remove both these positions, both position from stack 2 and the parenthesis from stack 1. Now we move to O, we skip it, we move to another closing parenthesis. Now what we see is that on the top we have an opening parenthesis which can cancel out the current closing parenthesis. So we pull this out and we pull the position. We just move to another character. D, skip it, E, skip it, and then we move to the last closing parenthesis, and the stack is empty for sim. So we simply add it to the stack 1. So after this entire operation from line number 8 to line number 23, on the current example, these two things will be on stack 1 and stack 2. So stack 1 will have a closing parenthesis and stack 2 will have its position 12. Now, after we are done with this operation from line number 8 to line number 23, we just formulate the result using a string builder. So what we do is, because stack is a last in first out, so we iterate over the current string or the given string from end, and whenever we find the matching position on the current string with the top value on stack 2, then we just simply continue, because that's a invalid parenthesis and we have to remove it. So for example, in the given string LeetCode, LeetCode, we see that stack 2 has position number 12. So when we iterate over the string from the end, we see that 12 matches with the topmost position. We pop this 12 out and we continue, because we don't want to add this or append this closing parenthesis to the resultant string. So what happens is we don't add last closing parenthesis to the resultant string. After this, we simply keep on adding the values into the string builder like this. So this will be the resultant string builder. After this, we just reverse it and return the result back. So if I run this, I submit it. So this is how it works. Now I tried to modify this solution by doing some basic changes. For example, you can what you can do is instead of using a string, if instead of operating on the string directly, you can convert it into a character array and then mark the position in that character array with some kind of character, let's say dollar or let's say hash, to mark the positions of parentheses which are invalid, and then use them to remove use those some random character to mark that position and then remove those invalid positions and make a resultant string. Or what you can do is instead of using stack2 or the stack for holding the positions of the parentheses, you can simply use a dequeue. And using a dequeue, what you can do is instead of iterating from the end, you can simply iterate it from the front and create a string builder. In that case, you don't have to reverse it, you can simply return the result. Overall, the time complexity will be order of n, and the space complexity is also order of n. The time complexity is order of n because we are iterating over the characters only once. We are checking each character only once and we are adding it to the stack and popping it out. So it's an order of n time complexity, and the space complexity is order of 2n, but it doesn't matter, it still is order of n. So in this way, you can solve this question in a very easy way using two-stack technique. Now, I have not checked out the official solution given on LeetCode for this question, but I'm hoping that that should be somehow similar to this technique. But if I find something interesting in that, or if there is an optimized solution to that, then I can upload a video on that too. So thanks for watching this video. I hope you like it.